Regression. Introduction. Regression analysis. The word regression meaning to come back to or a return to a previous and less advanced or worse state. Right, that is the meaning of regression. So based on that we are taking the analysis, so it is called regression analysis. For example, you take if parents were very tall, right, the children tends to be tall, right? Parents are tall means children's also tall, but if you are getting shorter than their parents, why? Right. So similarly, if parents were very short, the children tend to be short, but taller than their parents were. So we are going to analyze this type of statements, this type of problems. That discovery is called regression, right? So independent variable, the variable which is independent of other variables in an experiment, it is called independent variable. Suppose if we are having y is equal to x plus 2, right? So if you are giving values to x, so x is independent of anything. So x is equal to 0, 1, 2, x takes any value from the real line, right? Whatever it is, then y based on the x value, right? So x is called independent variable and y is depend on x, so it is called dependent variable, right? Independent of other variable in the experiment. The change in the variable influence the dependent variable, right? Or the variable to be estimated. Y is equal to x plus 2. Y is the variable to be estimated. That is the dependent variable. So changes in the independent variable influence the dependent variable. Predicted in an experiment. So y value to be predicted based on the x value. The independent variables is the cause, right? It is a cause. Example, someone's age might be independent, so independent only, right? Definitely. Other factors, eat, how much they are eating, how much they are going to school, how much television they watch, any variable or anything will not affect their age, right? So independent. Dependent variable, the variable which is to be understood or estimated or predicted or measured in an experiment. I explained y is equal to x plus 2. The same thing, right? Is called dependent variable. Its value depends on changes in the independent variable. The dependent variable is the effect. So independent is effect and independent is cause and effect. It is also called outcome or responsible variable. It is called outcome. So the independent variable is input, right? This one is output. Example, in an experiment, checking the test scores of students based on the their time spending in training. The students test score depend on the special training, right? So clearly the test score is the dependent variable. How long a student study before examination, independent, has an impact on the test score, dependent variable, right? Next, regression is statistical method used to estimate the relationship between dependent, that is outcome variable, right? So dependent variable, that is outcome response variable, and one or more independent variable, input variables, right? The dependent variable is denoted by y and independent variable is denoted by x. Example, relation between person's age and height. If age increases, height increases. So relation, what is the relation? A person's height increases as his age increases. They have a linear relationship. Relation between sales and budget for its advertisement. There is a advertisement expenditure increases, sales tends to increases, right? If they spend more on advertisement, so it will reach the customer more, so sales will automatically increase. So applications, the main uses of regression analysis for or forecasting, time series modeling, and finding the cause and effect relationship between variables. Regression is a statistical method used in finance, investing, business, medical science, engineering. There are so many uses in regression line. So this is very important topic. Advantages: regression models are simple and easy to understand. The output of regression models is an algebraic equation that is easy to understand and used to predict. Easy to solve also, right? Next, the predicted power of regression models mathematically, and sometimes performs better than the competitive models. So more models are there, so competitive models. Regression models can be include all the variables that one wants to include in the model. Regression modeling tools are available universally, right? Disadvantages: regression models cannot work properly if the input data has error. Regression models are susceptible to collinear problems. Strong linear correlation between the independent variables, right? Linear correlation independent variable, then it will be doubtful. As the number of variable increases, the reliability of regression models decreases. Regression models do not automatically take care of non-linearity. So types of linear regressions. Linear regressions divided into two types mainly: simple linear and multiple linear. So simple linear regression, in this the relation between dependent and independent variable is linear. That is simple linear. It is used to estimate the relationship between dependent and independent variables. So example, the relation between how height increases or decreases depending on the person's weight or age. The relation between how much salary of a person earns based on their level of education. Multiple regression. In this, the relation between dependent and independent variables is linear. It is used to estimate relationship between a single dependent variable and two or more independent variable. Example, predicting a student's final exam score. That is dependent variable based on his study time, attendance, so how he are attending the classes regularly. Then model exam score, so how much he is scoring in the model exam, etc., etc. These are all independent variables. Predicting a house price, dependent variable based on location, where it is located, in the city or village, right? Size, it is a big house or small house, right? So number of rooms, if it is with how many rooms, right, etc., right? Line of regression. The line of regression, so y on x is the line which gives the best estimate for the value of y for any specified value of x. The line of regression x on y is the line which gives the best estimate for the value of x for any specified value of y. Line y on x, x on y, right? The standard regression line y on x is given by y is equal to a plus bx, where b is called the regression coefficient y on x, right? Similarly, for x on y, x is equal to c plus dy. D is called the regression coefficient x on y. Equation of regression lines. Regression line y on x is given by y minus y bar is equal to r sigma y by sigma x, x minus x bar. We know a straight line equation with slope m passes through the point x1, y1, y minus y1 is equal to m into x minus x1. Same, right? Here regression line y on x, y minus y bar equal to r sigma y by sigma x, x minus x bar. Similarly, x on y, x minus x bar equal to r into sigma x by sigma y, y minus y bar. X bar is the mean of x, summation x by n, number of items. Y bar is mean of y. R is the correlation coefficient between x and y. Sigma x, sigma y, standard deviation of y, x, right, respectively. Standard deviation of x, sigma x, standard deviation of y, sigma y. So regression coefficient y on x, that is that byx, that is equal to r sigma y by sigma x. See regression line y on x, y minus y bar. I told you y minus y1 equal to m slope x minus x1. Similarly, here that is called regression coefficient. Y minus y bar equal to regression coefficient into x minus x bar, r sigma y by sigma x. Regression coefficient x on y is given by bxy, which is equal to r sigma x by sigma y from the second line. So this is standard result, r correlation coefficient, sigma x, sigma y respectively, standard deviation of x and y. Equation of regression lines. So regression line y on x, that is equal to y minus y bar equal to byx. Instead of r sigma y by sigma x, I am using the notation, that's all. Right, x minus x bar. So x on y, x minus x bar is equal to bxy into y minus y bar. Properties of regression line. So these are all the important thing. So product of the coefficient of regression byx into bxy, which is equal to r into sigma y by sigma x into r into sigma x by sigma y. Sigma y get cancelled, sigma x get cancelled, so you will get r square. So r is equal to plus or minus root of byx into bxy. This is very important property of regression coefficient. Thanks.